So let's do a conversion problem involving spherical coordinates. Let's find an equation in spherical coordinates for the surface represented by each rectangular equation. So we're going to do two of them. Let's start with the first one. It's going to be the equation of a cone, and the cone will be x squared plus y squared equals z squared. So we're going to use our formulas for x in terms of spherical coordinates. It's rho sine phi cosine theta. Y is rho sine phi sine theta. And z is rho cosine phi. And then we're going to square everything. So this becomes rho squared sine squared phi cosine squared theta plus rho squared sine squared phi sine squared theta equals rho squared cosine squared phi. And I can factor out on the left a rho squared and a sine squared phi. And I'm left with cosine squared theta plus sine squared theta. And I know that cosine squared plus sine squared, what's that equal to? That's going to be equal to 1. So this just says rho squared sine squared phi equals rho squared cosine squared phi. And if I divide by rho squared here, I'll get sine squared phi equals cosine squared phi. If I divide by cosine squared, I'm getting sine squared phi over cosine squared phi equals 1. Well, sine squared over cosine squared, that's also known as tangent squared. So if I take the square root, I get tangent of phi is plus or minus 1. So tangent is 1. Remember that we have this restriction on the angle phi. It's between 0 and pi. So what are my angles between 0 and pi where tangent is either 1 or negative 1? Those angles would be pi over 4 or 3 pi over 4. And so pi over 4, this part is giving you, so if I draw this cone, kind of real quick sketch it out for you. We have this part here, and we have this part going along the bottom. So the pi over 4, that's giving you the upper half of the cone, and 3 pi over 4, this is giving you the lower half of the cone. All right, so let's look at one more, B. Let's look at the equation of a sphere, x squared plus y squared plus z squared minus 4z equals 0. Well, if I look, x squared plus y squared plus z squared, I can replace that all with rho squared. And then I'm going to substitute in for this z, minus 4. Z is rho cosine phi. So here I can factor out rho minus 4 rho cosine phi or sorry, there wouldn't be a rho in that second one, just minus 4. And then from this part right here, we're going to get that rho equals 4 cosine phi. So that's how I can write the equation of the sphere there.